This is one of my favorite problems. Right, so we have in this problem $4 stamps for $2.50, $1.20, and $1 stamps. Of course. And we are making use of the statement that Annie went to the post office and bought a collection of 6 of each of the following stamps. What is the total cost of the stamps? So what do we do then? We have 6 of each. So the easiest way to find the total cost of 6 of each is to add all of them and multiply the result by 6. So add all of the prices for the stamps and then multiply the result by 6, and we get $52.20. She had to post a parcel and the cost of postage is $25.70. What stamps can she select from the collection to make up the amount if she must use as many $4 stamps as possible, and she need to use in another case all of her $1 stamps? We are going to use in the first case as many $4 stamps as possible. So let's go. We have $25.70. She has to use as many $4 stamps as possible, and we are going to use 5 of them. 5 times 4 is 20, so the total cost for the $4 stamps will be $20, and we have $5.70 remain. Next, we will use one $2.50 stamp. So we'll take that $2.50 from the $5.70 that we have, and we will be left with $3.20. We will next use another $1.20 stamp. So a single $1.20 stamp in this case, take $1.20 from $3.20, and we will get $2. Finally, we will throw in 2 $1 stamps. Right. And her money will be reduced to $0.00. So we have completed our task. So one may be hasty to use the greatest number of $4 stamps possible, using 6 of them because she has a total of 6 of each. So using 6 of them will fall short of $25.70 by $1.70. Right. Which cannot be exactly broken down by the value of the stamps that we have left. So if we subtract $24 from $25.70, we will have $1.70 left. And the $1.70 will not be able to be broken down by the value of the stamps that we have. So we could not have used 6 $4 stamps. The stamps that she may choose from the collection will be highlighted: 5 $4 stamps, 1 $2.50 stamp, 1 $1.20 stamp, and 2 $1 stamps. Now, in the other case, she must use what? Must use all her $1 stamps. Do not forget, she cannot use more than 6 of any stamp because she has only 6 of each. So that's the cost of the parcel again. The cost of posting the parcel is $25.70. Use all 6 of her $1 stamps and see what we get. So 6 of them, taking away $6, we have $29.70. use four $4 stamps again. So for $4 stamps we have $16. Of course, we could not have possibly used 5 because 5 is going to go over to 20 and we only have $19.70 left. So we use $4 stamps to $16 and we subtract that $16 from $19.70, so we have $3.70. We are going to use one $2.50 stamp, $2.50 from $3.70. We have $1.20 left, and we are going to throw in one $1.20 stamp, right, and that finishes our calculation. Make sure that the remainder after each step can be broken down by the value of the stamps that we have. The stamps that she may choose from the collection will be that 6 $1 stamps, 4 $4 stamps, 1 $2.50 stamp, and 1 $1.20 stamp. Now, we have this question. What is the largest number of stamps that she can use from the collection to post the parcel? What is the largest collection of stamps? The maximum number of stamps possible is 17, because they ask for that. What is the largest? And they say list the selection of stamps she can use. Now, if she is going to use the maximum number of stamps, I think that she should use the maximum number of the stamps that have the least value. So, because they have the smallest value, we will use the greater number of them. So, the largest number of stamps will be obtained by using the largest number of the lower value stamps. So start by using all of the $1 stamps, and do not forget that she has only 6 of each. So we use all of the $1 stamps and we have $19.70 left. Then she will use as many of the $1.20 stamps as well as many. She'll use all of them. So she used all 6 of them. Right? She used $7.20, and we subtract that from 1970. We have $12.50. So now we have only the $2.50 stamps and the $4 stamps left. So what do? It would be good if we realize that the amount left is equivalent to 5 $2.50 stamps, and even better if we also realize that the inclusion of any $4 stamp will be a disaster. So if we included a $4 stamp, that would really throw our calculations out of the window. But we realize that we have 5 $2.50 stamps right there, so we can use them. As a matter of fact, we have 6, but we only need 5 out of them this time. And that completes the calculation. The list of stamps that she may choose will be highlighted, and it is 6 $1 stamps, 6 $1.20 stamps, 5 $2.50 stamps. So we have used as many of the stamps with the lowest values as possible. Simplify the given expression. The bases are the same. Add the indices when we are multiplying, and in the case of division, subtract the indices. Of course, when we are manipulating indices, in the case that we are multiplying numbers with the same base, we add the indices, And when we are dividing, we subtract the indices. So we will have x to the power of 2 plus 3 minus 4. 2 plus 3 is 5 minus 4. So 5 minus 4 is 1. X to the power of 1, which is equal to x. For a fractional index, the root is the denominator. In the case of a square root, the root is 2. It is appropriate to convert all the indices to fractions. So we have the square root of ab cubed. Here we have a to the power of 3 over 2, b to the power of 5 over 2. So in the case of a fractional index, the root is the denominator. So we are talking about square root. The root is 2. The denominator is 2. Of course, in the case of a that we have here, the default index is 1. So we will have, in this particular case, a to the power of a half, or 1 over 2, and b to the power of 3 over 2. In this multiplication relationship, we will add the indices of those that have the same base. So in the case of a to the power of 3 over 2 and a to the power of 1 over 2, we will add those because they have the same base, and also in the case of b. So we will have a to the 3 over 2 plus a half and b to the power of 5 over 2 plus 3 over 2. The relationship is a multiplication, so we are adding the indices. So we have 3 over 2 plus 1 over 2 is 4 over 2, which is 2. And here we will have b to the power of 8 over 2, we are adding these, which is equal to 4. So a to the power of 2 and b to the power of 4. First, we will find f of 2. In finding f of 2, we will replace x with 2 in this function. So in the function where we see x, we will replace it with 2. So f of 2 is equal to 2 times 2 minus 3, and that is equal to 1. We are now required to find the function f inverse of x. And of course, in finding the inverse of a function, we perform the opposite of each arithmetic operation, and we perform them in the reverse order. So in this particular case, we are multiplying by 2 and then subtracting 3. We will then add 3, divide by 2. So we will not only reverse the arithmetic operation, we will perform them in the reversed order. So 2x minus 3, or 2 multiplied by x minus 3. So we will have x plus 3 divided by 2, and that will be the inverse function, f inverse of x. We will continue to find f inverse of 0. To find f inverse of 0, all we need to do is substitute 0 in the place of x in this function f inverse of x. So we substitute 0, we have 0 plus 3 divided by 2, which is 3 over 2, and that's all there is to it. Now we will proceed to find f inverse of f of 2. So we will find f inverse of f of 2. We may progress by finding f of 2, then causing the function f inverse to operate on the result. So we find f of 2, and whatever that value is, we cause f inverse to operate on it. However, we know already that f of 2 is equal to 1. So, since f of 2 is equal to 1, where we see f of 2, we put 1. So we are actually finding f inverse of 1, in which case we are substituting 1 into the function f inverse that we have determined right there. So 1 plus 3 divided by 2, and that is equal to 2. 1 plus 3 is 4, divided by 2, we have, that is equal to 2. We have a table that gives the temperature of a liquid T minutes after heating. So in this particular case, as we can see, as the time is increasing, the temperature is decreasing. So the temperature is decreasing as time is increasing. So the liquid is undergoing the process of cooling. We are going to draw the graph of the function, but first we have to plot the points. So let us plot the points. First, we have 0 for the minutes and 84 for the temperature. So how do we represent that? We first, t is equal to 0. The location of the point is dependent on temperature only because the time is equal to 0. So, time is equal to 0, temperature is equal to 84. We plot that point right there. Then, we are going to move to the point for which time is equal to 10 and the temperature is 61. 10, and then we go up to 61 and we plot that point right there. 20, 40. So the time in minutes we have is 20 to come right there, and the temperature we go up to 40. Let us plot the other points. So we are just going to plot 30 for the minutes and 29 for the temperature. Time in this particular case is 40 all the way here. Then we go up to 27. Minutes. After 50 minutes, we go up to 26, and after 1 hour, which is of course 60 minutes, the temperature will be 25. The curve may be drawn, and we are required to draw a smooth curve through all of those points, and that is what we call a cooling curve. And there we have our cooling curve. We will now determine the temperature of the liquid after 15 minutes. In order to do that, we will find or locate 15 minutes, and that is of course on the time axis, and we draw a vertical line to the curve. Then we will draw a horizontal line to meet the temperature axis, and that is the temperature corresponding to a time of 15 minutes, and that is 50 degrees Celsius. We will then determine the rate at which the liquid is cooling when time is equal to 30 minutes. So when time is equal to 30 minutes, we will determine the rate at which the liquid is cooling. From graphs, rates are determined by finding the gradient. In order to find the gradient at t is equal to 30, draw a tangent to the curve at the point on the curve where t is equal to 30. T is equal to 30 right there. We will draw our tangent, which is a line that barely touches the curve at one single point, does not cross the curve, does not run along the curve, but it barely touches the curve at that single point. And at that point, t is equal to 30, and that is our tangent. Next, we will find the gradient of the tangent. In order to find the gradient of the tangent, we will find two convenient points through which the tangent passes. If we can determine 2 points through which a line passes, we'll be able to determine the gradient of that line. So that point that we have right there is 10, 40. And we can find another convenient point, and it is usually very good to find the 2 points, to locate the 2 points suitably far apart, because that will increase the accuracy of our calculation. 65, 10. Use the formula for the gradient of a segment that join 2 points. We are going to use the formula for the gradient of a segment in order to determine the gradient of that line. So we will use 40 minus 10 to be divided by 10 minus 65. So we have y1 minus y2 over x1 minus x2. Do not forget that we may use y2 minus y1 over x2 minus x1, and that is irrespective of the point that we are going to be using as x1 y1 or x2 y2. Simplification gives the rate is equal to negative 0.55 degrees Celsius per minute, and the gradient has units. Where applicable, the gradient determined from a graph should have units. Temperature was divided by time, and this should be reflected in the units of the gradient. So temperature divided by time. So we have degrees Celsius per minute. In the case of the gradient, the value obtained from the graph that was done by hand is different from the one that was obtained from the graph constructed on the computer. It is for us to understand that a graph has never been considered by mathematicians to be perfect. A graph is at best an approximation, and sometimes a very rough approximation. Unless calculus is used, and it is not included in topics at this level, the values obtained by different candidates will vary. The examiners expect that candidates will draw a suitable tangent and use the tangent to obtain a value for the gradient of the curve at the point of tangency. Let us say that the tangent was not properly drawn. The candidate may be penalized for that. However, if the tangent is used in the correct way to obtain, no matter how ridiculous the value may occur to be, the candidate will incur no further loss of marks. So then, we will not expect all students to get that exact same value, but the students will have answers that are basically very close to a single central value. Let us solve the pair of simultaneous equations in which one is a quadratic and the other is linear, and we will use the method of substitution. We are going to take from equation 1 and substitute into equation 2. So if we examine equation 1, y is equal to, if we transpose this to the right hand side, 27 minus 4x. y is equal to 27 minus 4x, and of course we are going to label that equation 3. What we call the substitution equation, we always label this equation because at the end it is the easiest equation to use in arriving at the values of y after we have calculated the values of x. So we are going to take from 1 and we are going to put into 2. Therefore, in 2, where we see y, we put 27 minus 4x. So x multiplied by y, x multiplied by 27 minus 4x. And of course, it is important for us to include brackets because the 27 is going to be multiplied by the x and the negative 4x is going to be multiplied by x. So it is the entire expression 27 minus 4x that will be multiplied by x. Expanding the brackets, this is the result that we obtain. Of course, x times 27 is 27x, and x times negative 4x, we get negative 4x squared. We are going to simplify this into a trinomial, in which case this negative 4x squared will be right there. We have 27x plus x, that's 28x, and of course the negative 40, not to be left out. We have two adjustments that we can make to this particular problem. It is not impossible to solve a trinomial with the x squared coefficient being negative, but let us avoid doing that. Also, all of the coefficients that we have there, all of the terms that we have there are multiples of 4. So instead of dividing through by 4, then changing all the signs, we are going to divide through by negative 4. So we have dividing through by negative 4, we have negative 4 into negative 4, that will cancel. Then we have negative 4 into 28, so that is negative 7. And we have negative 4 into negative 40, that is a positive 10. We need to factorize this trinomial by saying what two numbers multiply to give 10, and when we add them, the result is negative 7. There's no doubt that the answer is negative 2 and negative 5. But because the coefficient of x squared is 1, we may just write down the two factors, x minus 5 and x minus 2 equal to 0. Of course, solving that equation, we have x is equal to 5 and x is equal to 2. Those two values will be substituted in the substitution equation, which is this one, because it is ready to generate the values of y, because it has y is equal to something. So whatever you put here, the value of y will be determined quite easily. So we're going to substitute into that substitution equation, which is equation 3, and we get y is equal to 27 minus 4 times 5. 27 minus 4 times the value of x is 5 in that case, and of course 4 5s 20. 27 minus 20 is 7, so y is equal to 7. And the other one, y is equal to 27 minus 4 times 2. 4 times 2 is 8. So 27 minus 8 is equal to 19. So y is equal to 19. So the value of x, that is 5, has generated the value of y, that is 7. When x is equal to 5, y is equal to 7. The value of x, 2, generated the value of y, 19. So when x is equal to 2, y is equal to 19. The shaded area in the diagram shows the solution of a set of inequalities in x and y. The variable x represents the number of boys in a cricket club, and y represents the number of girls in the cricket club. Use the graph to answer the questions. So, the first question is, State using arguments based on the graph whether the cricket club can have as members 10 boys and 5 girls. Can it have 10 boys and 5 girls? Take a look. So, well, we have answered that to say no, but we need to demonstrate that the answer is actually no. So we have 10 boys and 5 girls. 10 boys and 5 girls will fall out of the shaded region. Therefore, the club cannot have 10 boys and 5 girls. But can it have 6 boys and 6 girls? Yes, it can have 6 boys and 6 girls. That is your point. 6, 6. So the point 6, 6 will fall in the region. Therefore, we are sure that the club can have 6 boys and 6 girls. Now, we are going to use the lines that we have to write down the associated inequalities. Right? So we are going to use the lines and write down the inequalities. Remember that for the most part, when we look at CSEC question papers, we are required to determine the inequalities and then use the inequalities to arrive at the line. In this particular case, we will use the lines that were drawn for us already and arrive at the associated inequalities. So let us go to the first one. There is a line whose equation is already known, and we have the equation right there. The shaded region is below the level of the line. The line is unbroken, indicating that the values on that line may be included in the inequality. So that's a very big mouthful statement, but let's see what we can highlight from it. The region is below the level of the line. So we will have y is less than. The line is unbroken, indicating that the values on that line may also be included in the inequality. So y is also equal. So y is less than or equal to, what do we have on the right hand side? Negative 4 over 5x plus 12. And that is our first one. Notice that for every point on the next line, the y-ordinate is twice the value of the x-ordinate. So on that line we have 10, 20. We have 5, 10. Do we have another? Well, we do not have to include any more. The value of y is twice the value of x. So its equation is y is equal to 2x. The shaded region is below its level and the line is also unbroken. So we know that is representing less than or equal to. So we have y is less than or equal to 2x. The final one is a horizontal unbroken line that touches the y-axis at 2. The region is above that line. So the region is above the line in this particular case. So y is greater than or equal to 2. The company sells uniforms for the club and makes a profit of $3 on a boy's uniform and $5 on a girl's uniform. So the total profit is equal to the number of boys' uniform multiplied by the cost, or the profit in this particular case. And we are going to add that to the number of girls' uniform multiplied by the profit. And of course, the number of boys uniform is X, and the number of girls uniform is Y. So the profit will be 3 times X plus 5 times Y. And we need to calculate the minimum profit that the company can make. Now, of course, it is going to be obvious which one of the vertex that we should use. But let's see what happens. The vertices are 1, 2, 4.25, 8.5, 12.5, 2. Now, if we should check them numerically, we are looking at the minimum profit. So, if we look at these numbers, in 1, 2, just considering 1, 2, 1, 2, 1 is less than 4.25 and 2 is less than 8.5. Therefore, for the minimum, this vertex will give less than this. Also, over here we have 1 is less than 12.5 and these two are equal. So, these two ordinates will contribute the same value. But this one will contribute a value that is less than this one. Therefore, we are sure that this point will eventually give the minimum value or the minimum profit. However, we can have no fraction of a boy or girl. Therefore, since the values that we have on this graph, the X represent the number of boys in a cricket club and the values of Y represent the number of boys in the cricket club, we cannot possibly have any fraction for boys and girls at all. So we are sure that these vertices are out. No fraction of a boy or girl. So the only vertex that can ever apply, whether it would be maximum or minimum, would be 1, 2. So we'll insert these values into the profit function in order to arrive at the value of the minimum profit. So P minimum is equal to 3 times the value of X, which is 1, plus 5 times the value of Y, that is 2. So we have 10 plus 3, which is equal to $13. We always think that this is one of our favorites. However, let's see how this one works itself out. In the first case, we are required to find the angle PTS. That is PTS. Let us first calculate POS. It is inside of the isosceles triangle in which one of the equal angles is alternate to 26 degrees. So, of course, we have the arrows showing that these two lines are parallel. So we have a Z right there. So we have those two angles. They are equal. But of course, this is one of the small angle in the isosceles triangle. One of the equal angles of the isosceles triangle. So we have 26 degrees here and 26 degrees here. So we will find POS now. POS is the rest of 180 degrees. Angles in a triangle are to give 180 degrees. We have 26 and 26. 180 minus 2 times 26. So POS is 128 degrees. If two angles are subtended by the same arc or chord, the one at the center is twice the one at the circumference. There we have it. Here is our arc. We have this one subtending the arc, and we have this one subtending the arc. The one at the center is 128. The one at the circumference, which is PTS, is half of it. So 128 divided by 2 is 64 degrees. We need to find RPQ, which is, let's see, RPQ. RPQ. So how do we do that? We are going to use as one of the premises of our argument that the tangent meets the radius at right angle. There we have the radius going from the center to the circumference, and of course we have a tangent right there. They meet at 90 degrees. This angle is 26, this one is 26, so the angle RPQ, the rest of that 90 degrees. So we have RPQ is 90 minus 26 minus 26, which is equal to 38 degrees. In the diagram, O is the center of the circle of radius 8.5 centimeters, and AB is a chord of length 14.5 centimeters. Calculate the value of theta to the nearest degree. So, the chord is 14.5 centimeters and the radius is 8.5 centimeters. Therefore, we will have all of the sides of that triangle. So we now have all three sides of the triangle. We may use the cosine rule to find the angle. So cosine of this angle that we have right here, cosine of that angle is equal to this one squared, the two sides that form the angle, we add them. 8.5 squared plus 8.5 squared, we subtract the one that does not form the angle, 14.5 squared, that is what we are going to subtract, and of course that is divided by 2 times the product of the two sides that form the angle. So the two sides that form the angle are added here, the other one is subtracted, which is different, and of course the two sides that form the angle are multiplied here again, and this is simplified, and that will give the cosine of the angle. So the cosine of the angle is negative 0.455. So theta is equal to cos inverse of negative 0.455, which is equal to 117 degrees. Calculate the area of the triangle AOB. The area of any triangle can be calculated by taking half of the product of any two sides and multiplying that result by the sine of the angles that the two sides form. So we have these two sides. We know that 8.5 is the radius. So over on this side, 8.5 is the radius again. So we have 8.5, 8.5, the two sides that form the angle. So we have area is equal to a half, which is 0.5, of the product of the two sides that form the angle, 8.5, 8.5. These two sides that form the angle, multiplied by sine of the angle that the two sides form, and that area is equal to 32.2 centimeters squared. Now we are going to determine the area of the shaded region. We will use pi is equal to 3.14. The area of the shaded region is equal to the difference between the area of the sector and the area of the triangle. So we take this area of the entire sector, the area of the entire sector, and we have the area of the triangle right there. So the area of the shaded region is equal to the area of the entire sector minus the area of the triangle. So we will have to find the area of the sector first. So let us find the area of the sector. How do we find the area of a sector? The angle associated with the sector over 360 degrees times the area of the entire circle. So the area of the sector is a fraction of the area of the circle. The fraction is determined by this angle that we have here. So 117 over 360 multiplied by pi r squared, and that is it, 73.7 centimeters squared. So we will subtract the values that we have, the 73.7 that we have just calculated, and the area of the triangle that we have calculated on the previous slide. So the area of the shaded region is 41.5 centimeters squared. We next need to calculate the length of the major arc AB. The length of the major arc AB. And I think that problem was stated with major because most students and most times we are always thinking to calculate the length of the minor or the area of the minor sector or what. But this time it says major, right? And I'm sure that some students would have gone merrily along and would have calculated the length of the minor arc. But how do we know how to calculate the area of that major arc? The length of the major arc is associated with what? This angle that we have over here. So this one is for the minor arc, this one is for the major arc, and in order to determine that angle, we say 360 minus 117, and that is equal to 243 degrees. That is the arc that we are talking about, and that is its associated angle. So the arc is a fraction of the circumference, and the fraction is determined by the angle associated with the arc divided by the angle of one revolution. So we will have 243 over 360, and that is going to be multiplied by 2 pi r, and the result is 36 centimeters. A ship leaves port R, sails to port S, and then to port T. The bearing of S from R is 112 degrees. The bearing of T from S is 033 degrees. The distance RT is 75 kilometers, and the distance RS is 56 kilometers. Draw a diagram showing the journey of the ship from R to S to T. And of course, we have some details that we need to include on the diagram as we go merrily along. The first line shows a bearing of 120 degrees. Horizontal is 90 degrees, so we expect the line to slope a little below the horizontal. Of course, 90 degrees is east. And the east, of course, is represented by direction exactly to our right. We expect the line to go in a direction towards the right, but we expect it to go a little below the horizontal. So that is our first line. The other one shows a bearing of 30 degrees, of course, which is far less than 90 degrees. So we are sure that it is not going to go exactly to our right, but it is going to be somewhat inclined. As a matter of fact, we know that to our right is 90 degrees, so our line showing 033 degrees will be like that. As a matter of fact, we are not drawing the diagram to scale, we are just drawing it with the idea of approximation, or if not a close enough approximation, a rough approximation of what the journey should look like. The triangle may be completed. The bearings are taken from R and S. The north lines must be at those points. So if we are going to be inserting bearings, we have to have north lines. No bearings without north. So those are our north lines. And of course, the first bearing that we have is 112 degrees, and the second one is 033 degrees. 112 degrees is taken from R and must be at that point, and 033 degrees must be at S. R is at the beginning of the journey and T is at the end. S must therefore be the intermediate point. So those are the points. The distance is 75 kilometers and 56 kilometers must also be shown. RS is 56 and RT is 75. We will now do some calculation. So calculate the size of the angle RST. This one. RST. We have this part already. We need to find this part of the angle. Adjacent angles of a parallelogram are supplementary. That means they add to give 180 degrees. So we have this angle here and it is adjacent to this one. Why parallelogram? Because this line is north. This one also is north. So they are parallel. So this figure is a parallelogram. If this is 112, then this one will be the rest of 180 degrees. Adjacent angle or consecutive angles of a parallelogram add to give 180 degrees. So the other angle that we have there is 68. So RTS will be the sum of those two angles. 33 plus 68 is equal to 101 degrees. The other angle RTS, this one RTS, we may calculate this one RTS. In calculating RTS, we may use the sine rule. In the case that we are sure that an angle is going to be less than 90, which is an acute angle, if we are sure that the angle is going to be acute, then we may use the simple sine rule to determine its value. It has to be acute because this angle that we have just calculated is 101. So the other two angles will add to give 79. 79 itself is an acute angle. Therefore, each one that adds to give the 79 must also be an acute angle. So we are sure that the angle is going to be acute. So we may use the sine rule. And of course, the sine rule is applicable when we have one side of a triangle, a known side, and a known angle that are opposite to each other. And the known side that we have is the 75, and it is opposite the known angle that we have just calculated to be 101 degrees. So what do we say? Sine of the one that we are trying to find, RTS, over the one that is opposite to it, the side that is opposite to it, 56, is equal to sine 110 to be divided by 75. We may transpose the equation, and of course simplification will give us the sine of RTS to be 0.733. So RTS is equal to sine inverse of 0.733, which is equal to 47.1 degrees. We now need to determine the bearing of r from t. Bearing will be in a clockwise direction beginning at north. From t means that the angle is at t. The only angle that is not known is the one alternate to 33 degrees, which is this one. So let us show the setup that we are talking about. We have this one. So this one, this angle is the one that was not previously known. But we know that if we have this north line that is vertical right here, and we have one that is vertical right here, that these two lines are parallel. So these two angles are Z angles or alternate angles, and they are equal. So this is 33 and this is also equal to 33, and we know this to be 47, and all the way here is angle on a straight line, which is 180 degrees. So the only angle that is not known is the one that is here. We are, of course, trying to determine the bearing of r taken from t. So the line that goes from t to r is the one of interest, and of course we are going to start at north and go in a clockwise direction. So the bearing is equal to 180 plus 33 plus 47, and that turns out to be 260 degrees. The ship leaves port T and travels due west to a port X, which is due north of R. So we know that the ship is going to go like this until it is north of R. So let's show that. S is north of R. Triangle RTX is right angled. So the triangle that we form now, because this travels west and now it is north of R, we are sure that that triangle is right angled. Now we need to calculate the distance Tx. But in order to calculate Tx, we have to have some amount of information. We have 75 kilometers right here for the hypotenuse of the right angle triangle that we have, but we do not have another side, we do not have another angle. We can determine one of the angles, of course, because we know that all the way to here is 260 degrees. And the little angle here is what is left. But because this travels west, we know that as long as you know anything about bearing, you should know that west is 270 degrees. So we have the angle to be 270 degrees minus 260 degrees, and that is 10 degrees. Or we may say that we have here from south to west is 90 degrees, and we have what? 33 there and 47 there. So the rest is 10. That's another way to look at it. So RTX is 10 degrees. Now, the calculation of Tx, which is this distance, is based upon the fact that the angle that we have just calculated, 10 degrees, this side is adjacent to it. And the hypotenuse that we have is 75 kilometers. Therefore, adjacent and hypotenuse, we are going to be using the cosine trig ratio. So, adjacent, which is Tx that we do not know, over hypotenuse, which is 75, is equal to cosine of 10. And by transposition, Tx is equal to 75 cos 10. That turns out to be 73.5 kilometers. The position vectors of A and B relative to the origin are A and B respectively, common A and common B respectively, just as we see them right here. OB is B, OA is A. The point P is on OA such that OP is 2PA. So OP is 2PA. Let us insert the point P and digits that indicate the relative lengths of OP and PA. So OP is 2PA. So from O to P is twice from P to A. So we have 2 on this side and 1 on that side. No problem with that. Do the same for the point M. And it is said that M is on BA such that BM is equal to BA. So because they are equal, we may put 1 here and 1 there. BM is equal to BA. Show the point N and include digits that show the relative lengths of OB and BN. And of course, it is said that what? OB is produced to N such that OB is equal to BN. So OB is equal to BN. So we have 1 to 1 again because they are equal. Now we need to determine AB. To go from A to B, what do? We go like this and then that. So we go this way, which is negative A, and we have a positive B. So we have negative A plus B, right? Negative A plus B. And we may write that as B minus A. On the line, PA represents 1 part out of a total of 3. So we know this 1 out of a total of 2 plus 1. And of course, 1 out of 3 from primary school is 1 over 3, which is 1/3. So then, PA is 1/3 of A. And that is what PA is. We need to determine PM also. To go from P to M. To go from P to M is 1/3 of A plus, we are going to go half of AB because M is the midpoint of AB. So we're going to go half of AB. We know AB already. AB is B minus A. So we have what? 1/3 of A plus a half of B minus A. So we have 1/3 of A plus a half of B minus A. And that we will simplify. So how do we simplify that? We only have 1 occurrence of B. So a half of B goes right there. Now we have 1/3 of A, from which we will subtract a half of A. So if we should use 6 as a common denominator, 1/3 is 2 over 6. And a half is 3 over 6. So we have 2 over 6 minus 3 over 6. We have negative 1 over 6. So we have negative 1/6 A. And of course, we only have 1 occurrence of B. No problem with that. Next, we will prove that P, M, and N are collinear. That P, M, and N are collinear. Have we calculated any vector apart from PM? What about Mn? Mn is equal to a half of AB, because we have A to B, but M is halfway, so we have a half of AB plus b. So we have a half of AB, a half of AB plus b. And of course, AB is b minus a. So we have a half of b minus a plus b. How does this simplify? A half of b plus b is equal to 1/2 or 3 over 2b. And then we have minus a. So we have 3 over 2b minus a half a. We need to show that the points P, M, and N are collinear. Collinear means that they are on the same straight line. We can show that they are collinear by finding two vectors that involve the 3 points. Find two vectors that involve the points P, M, and N. Of course, we have one of the vectors calculated here already. We have PM, so we need a vector to include N. So we may find Pn or Mn. We have chosen to calculate Mn. And Mn is a half of AB plus B. And a half of AB is a half of B minus A. Remember, AB is equal to B minus A right there. Plus B. When we simplify that, we get 3 over 2B minus a half A. And we are purposely writing it in this form, a half of 3b minus a, because we want to write the other vector Pm in that form also. So Pm is equal to 1/6 of 3b minus a. So, because we can write the two vectors as products of the same basic vector, we are sure that the two vectors are parallel. And if the two vectors are parallel, then the 3 points that are involved in the 3 vectors are collinear. So writing the two vectors in this form and this form, being multiples of the same basic vector, 3b minus a, 3b minus a, we are sure that the vectors are parallel. And if two vectors that join 3 points are parallel, we are sure that the 3 points are on the same straight line, or we may say that the points are collinear. So there we have the two vectors, and they are products of the same vector. Finally, in problem 13, we will calculate the length of AN if A is equal to 6 over 2 and B is equal to 1 over 2. So, where is AN? AN. So, AN is AB plus BN. AB plus BN. AB is B minus A. And BN is B. So we will have what? AN is equal to B minus A plus B, which is equal to 2B minus A. And of course, we have the values of B there and A. B is 1, 2, and A is 6, 2. So we have 2 times 1, 2 minus 6, 2. So 2 1s, 2 and 2 2s, 4. And of course, we are going to be subtracting, and we get 2 minus 6, negative 4. 4 minus 2 is 2. And we need to find the length of that vector by taking the square root of this squared plus this squared. As we have it right there. Negative 4 squared is equal to 16. 2 squared is equal to 4. So we have there the square root of 20 and that is equal to 4.47 units. X and Y are two matrices where X is equal to negative 2, 0, 5, 1, and Y is equal to 4, negative 1, 3, 7. We need to evaluate X squared plus Y. To find X squared, we multiply X by X. No problem with that. So we have the upper times the left. Negative 2 times negative 2 plus 0, 5. Right there. And the answer goes to the upper left. The upper times the right. Negative 2 times 0, 0 times 1. And the answer goes to the upper right. Now we have the lower multiplied by the left. And the answer goes to the lower left. 5 times negative 2 plus 1 times 5. Finally, the lower multiplied by the right. The answer goes to the lower right. 5 times 0, 1 times 1. So we have that right there. Simplifying, we will get, this turns out to be 4. This is 0. So we have 4 here, 0 there. So we have 4. Then we have 0, 0. So we have 0. Then we have 5 times negative 2 is negative 10. Negative 10 plus 5 is negative 5. And of course, this one is 0. And 1 multiplied by 1 is 1. Now we need to add this value, which is x squared, to the one that we have there, which is y. So x squared plus y, and that is very simple. We add the corresponding elements. 4 plus 4 is 8. 0 plus a negative 1 is negative 1. Negative 5 plus 3 is negative 2. And 1 plus 7 is 8. No problem with that. It is said that the matrix 1, 2, 1, 3 maps 1, 2 onto its image 5, 7, and we are required to determine the 2 by 2 matrix that will map Q prime back to Q. So in order to do that, we know that the one that will do the reverse transformation will be the inverse of the matrix. So let us calculate the inverse of the matrix. So that is our matrix inverse, the inverse of 1, 2, 1, 3. So first we have 1 over the determinant 1, 3 minus 2, 1 or minus 1, 2. And then we are going to form the adjoint by exchanging the places of these two. The 3 goes there and the 1 down there, and we change the signs of these two. So we have a negative 2 there and a negative 1. When we simplify this, we get 1. And of course, 1 multiplied by anything is that same thing. So we have the inverse is 3, negative 2, 1, negative 1. The vertices of a triangle DEF are 5, 12, 2, 7, and 8, 4. The triangle undergoes an enlargement with center O and scale factor K. Its image is D prime, E prime, F prime, where D is 5, 12 and D prime is 7.5, 18. And we need to determine the value of K. So then, that's not very difficult. For an enlargement centered at the origin, multiplying an ordinate by the scale factor will give the ordinate of the image. So if we have 12 and its image is 18 under an enlargement centered at the origin, so we say 12 multiplied by the scale factor is equal to 18. Therefore, K, which is the scale factor, is equal to 18 divided by 12, and that gives us 1.5. If so be the case, we may write down the coordinates of E prime and F prime, because all we need to do is take that 1.5 and multiply by the other ordinates to find the ordinates of the enlarged image. So multiplying the coordinates of 2, 7 and 8, 4 by the scale factor of 1.5, we will have 2 times 1.5 is 3, 7 times 1.5 is 10.5, 8 times 1.5 is 12, and 4 times 1.5 is 6. So there's no difficulty there. Determine the 2 by 2 matrix that represents a clockwise rotation of 90 degrees about the origin. Now here we have the 2 points 1, 0 and 0, 1. That's the standard. We usually use the points 1, 0 and 0, 1 and subject them to the transformation. Of course, we are going to write them in the matrix, the 2 columns of the matrix. So we have the point 1, 0 is written as the first column here, and 0, 1 is written as the second column right there. So we say subject 1, 0, which is the first point, to a clockwise rotation by 90 degrees. So it will come down here. And this point will be 0, negative 1. 0, 1 is the point that is here. If we subject that to a clockwise rotation of 90 degrees, it will come right there. From here to there, which is from 0, 1 to 1, 0. So that's the point that we are going to have. And then this entire matrix will represent the rotation of 90 degrees about the origin. The diagram shows how the point 1, 0 and 0, 1 are written as the 2 columns of a 2 by 2 matrix and are subject to the transformation. Their images are written as the column of another 2 by 2 matrix, which becomes the matrix of transformation. Now, in order to determine the coordinates of some points under rotation, we will multiply the points by the matrix of transformation. So this is our matrix of transformation, and these are the points. We will multiply these points by this matrix. Of course, we may do this. This multiplied by this. Of course, we are not going to exhaust the first row of the first matrix as we have been accustomed to. When we are just multiplying matrices, we may do that. But when we are doing transformation, we will transform the points one at a time. Now look at this scenario. This multiplied by this. 0 times 7.5, that's gone. 1 multiplied by 18, we have 18 there. Now we say negative 1 multiplied by 7.5, that's a negative 7.5, and 0 times 18, that's 0. So we have negative 7.5 right there. So we have 18, negative 7.5. Notice what happens. In each case, we will expect the ordinates to exchange places, and the one that ends up at the bottom will incur a change in sign. So we need to just do the same thing here. That's a pattern that we can follow. Exchange places with these, and the one that goes there incur a change in sign. Exchange places with these, the one that goes to the bottom will incur a change in sign. And that is a pattern that we may follow when we are transforming points by the matrix responsible for a rotation of 90 degrees about the origin. The problem requires coordinates. Write the points in coordinate form. So the statement of the problem requires that we determine the coordinates. So when we are through, this is not the exact answer that is asked, so we will give them the appropriate answer. write these in coordinate form, and this is the result. For a transformation in the order A followed by B, we form the matrix product BA. So multiply the matrices of transformation in the reverse order. So whereas we did an enlargement followed by a rotation, we will multiply them in the reverse order. So the matrix of the rotation will go first, and the matrix of the enlargement will go second in the product. So this is what we have. Matrix of the rotation followed by the matrix of the enlargement. Because in order to arrive at the matrix product that is responsible for an enlargement followed by a rotation, we multiply the matrices in the reverse order. And this will be the resulting matrix.